Good morning everyone. I'm Nishant and I'm a student of the TED Young Thinker Academy. And I've always been fascinated by science. Whenever we think of science, we think of the eminent personalities such as Madame Curie, Isaac Newton, Albert Einstein and so much more. We think they were born legendary, that they already had these revolutionary ideas which transformed the world of science. But in actuality, they were also born as normal people. So what differentiated these people from people like us? Well, it was their sheer determination that changed these small ideas into the very next big thing. So who's to say that our ideas cannot become the very next big thing? No matter what your passion is, no matter what you like to do, you got to start somewhere. Which is why I'm right here standing before you to present on yet another innovation that might just turn into the very next big thing. I'm Nishant Kartik Nayak and this is my very first TED Talk. So before we actually start with the topic, let's discuss about something which we use on a day-to-day basis, something humanity cannot survive without, something as simple as electricity. What is electricity? I presume all of you must know what electricity is. It's basically the movement of charges, but it's this movement of charges that has powered humanity for decades. So how is this electricity generated? This electricity is generated from, as you all might know, non-renewable sources of energy for the most part, with three major sources: coal, oil and natural gas. But the problem with these non-renewable sources is the fact that they are non-renewable. The production of these resources takes millions and millions of years, but the rate at which we are using them surpasses the rate at which they are produced, and thus they are slowly being degraded and we are slowly using the stock up. And there will come a day when these resources will run out of hand, and that day is much sooner than you think. Researchers estimate that our current stocks of coal will not last for more than 150 years, and the oil and natural gas that we use, which are conventional sources of energy, will not last for more than 50 years. That's a short amount of time. Thus, it has become the need of the hour to find renewable sources, energy-dense sources, which can power the entire world. Now, before we go on to these alternative energy sources, which can substitute these non-renewable sources like coal, we need to see what makes an energy source the ideal energy source. There are basically three factors that go into this. The first one is the availability of this resource. That is why these non-renewable resources are so widely used. Once the raw material is met, then the energy production is continuous and it is spread all around the world. And this is the major disadvantage of the renewable resources that exist today. Hydropower plants need water bodies to operate, and that is not available at each and every corner of the world. Solar energy on ground is highly dependent on factors like availability of sunlight, weather, day and night time, the latitude of the place and so much more, which gives it an erratic energy supply. And wind energy is highly dependent on high-speed winds, which are not present all around the globe. The second factor is ubiquity. This is where the non-renewable resources fall short. This is what differentiated these renewable resources from the non-renewable resources. Renewable resources will last for a long amount of time, which is why these are the favorable energy sources for humanity in the long run. However, as I mentioned before, these non-renewable sources will not last forever and will extinguish as time passes. And the third topic, which is currently the most important out of all the three, is sustainability. The non-renewable sources which we have been using have also been degrading, but the major problem that they have been causing is the releasing of harmful effluents, harmful gases and so much more, which has been accelerating the rate of pollution to a very high extent, which is why the need of cleaner sources of energy is the need of the hour. So governments and concerned individuals all across the globe are finding ways to find renewable sources of energy, energy-dense sources of electricity, which can substitute these non-renewable resources. And one of them, the idea which I will be presenting today, is space-based solar power. Space-based solar power interestingly draws its roots from a sci-fi novel by Isaac Asimov. It was titled Reason and it was released in 1942. Since then, the technology and development of space-based solar power has taken place. And one of the most notable development was Peter Glazer's design, which basically suggested that energy from space can be beamed back to Earth in the form of microwaves. Now, to understand this whole aspect of how space-based solar power works, I have an imaginary concept for a satellite which is called as Helios, which stands for our purpose, that is harnessing electricity in outer space, and it aims to prove as an energy-dense alternative source of energy to these non-renewable sources of energy. The main principle behind taking this solar power to space is the fact that the energy density of solar power in space is much higher than it is on ground, and it's unfiltered by the atmosphere, and it is available 24/7 365. Aggregating to all the factors that go into this density of solar energy, we concluded that the density of solar energy in space is 44 times more than that on Earth, and it is continuous. It is available all throughout the day, unlike ground based solar energy, which is just available for half of the day, because at night the sun isn't there in the sky. So now let's look into the working of the satellite. So there will be two parts. First of all, the satellite which will be there in the space, which will capture the energy dense solar radiation, and the second one is the special type of antennas called as rectennas, which will be situated on the ground. We'll come to these rectennas later. First, let's go to the satellite. The satellite will have three main components. The first one being obviously solar panels, but these are unique solar panels. These are made of something known as multi-junction photovoltaic cells, which contain compounds like gallium arsenide, gallium indium arsenide, and etc. And why are we using these compounds? Because these have demonstrated high conversion efficiencies from solar radiation to electricity, and these have achieved efficiencies of up to 40%. In comparison, the silicon ones which we use on ground only have efficiencies up to 11%. So the solar panels which will be situated on the satellite Helios will be in the form of rectangular panels, which can be folded so that the payload can be easily launched into space. Now it is true that in space the atmosphere is not there, so there is nothing to protect the satellite from the harmful radiation of the sun. But this is where the magnetosphere of the Earth comes into play. The magnetosphere of the Earth is this region around the Earth where the Earth's magnetic field protects it from the harmful radiation of the sun. And since the satellite will be situated in the magnetosphere of the Earth, the orbit of the satellite will be in the magnetosphere of the Earth, thus it will be protected from harmful solar radiation. And a small satellite like Helios, which will have a solar panel area of approximately 400 meters square, can power thousands of Indian homes 24/7, 365 days a year without the need of any other alternate source of energy. So now we have had the solar panels which have converted this dense solar energy into DC electricity. Now this DC electricity will go into the satellite body. The satellite body will contain something which is known as a magnetron. A magnetron is basically something that will convert this electricity which we get from the solar panels into microwave radiation, which can be beamed back to the Earth. Now this magnetron was actually not discovered when solar panels were space based solar power was implemented before. So back then we used something known as a clashtron. But clashtron had very low efficiency and was a very complicated design of a microwave converting technology, and that is why the idea of space based solar power was discontinued for the moment. But with the discovery of magnetron, which were much more compact and much more lighter and much more efficient in converting this energy, the idea of space based solar power resurfaced as a potential alternative energy source. Now potential designs for potential materials which can be used to build the satellite body are aluminium, because it's lightweight, cheap and durable enough to survive launch, plus it has the radiative cooling properties which will keep the satellite cool. Kevlar will protect the satellite from space debris, and graphite and Teflon can act as dry lubricants for moving satellite parts. So now that we have had the microwave energy which is supplied by the magnetron, this will go on to a microwave antenna which will be located at the end of the satellite. This microwave antenna will beam this microwave radiation back to the Earth. But where to in the Earth? This is where the rectenna arrays come into play. The rectennas are basically this special type of rectifying antennas which will directly convert this microwave energy which we get from space into DC electricity, which can then be supplied into the electricity grid. There will be huge rectennas, rectenna arrays, which will be placed on Earth in various specific locations, and they will be aligned to the satellite so that the radiation that comes from the satellite will reach the rectennas. And these rectennas have also demonstrated high conversion efficiencies. So now thrusters is something that will not be directly involved in the energy conversion process, but will be needed to keep the satellite in orbit and for maneuvering of the satellite. So now that we have come to the basics of how the satellite works, I'll just recap everything once again. The solar panels on the satellite will convert the dense solar energy into space into electricity, which will then be converted by the magnetron in the satellite body to microwave energy, which will then be supplied to the Earth by microwave antenna. And rectenna arrays on ground will convert this microwave energy into DC electricity, which can then be supplied into locations all across the globe. So now that we have come to the basic working of the satellite, let's go into some commonly asked questions. The first question out of all must be, which orbit will this satellite be located in? Now since this satellite is beaming energy back to Earth, we'll need an orbit where the satellite can continuously beam this energy back to Earth into a specified location 24/7, 365. And that orbit is called a geostationary orbit, A geostationary orbit is basically an orbit where the orbital period of the satellite will match the rotational period of the Earth. So, if you see from a place, the satellite will appear at a constant point in the sky, and this will result in constant beaming back of energy to the ground, and this will supply energy 24/7, 365. Next up, why are we using microwaves to transmit this energy from space back to Earth? Well, that's because microwave is this type of electromagnetic radiation to which Earth's atmosphere is completely transparent to. Other radiations such as infrared etc. are opaque to the Earth's atmosphere. So, when we use the microwave radiation, they can surpass the Earth's atmosphere without any downgrade in the energy distribution, and thus they are used as a viable energy source. Plus, they have also demonstrated high conversion efficiencies of up to 90% in lab tested conditions. Where will the satellite be located? So, as I said, the satellite will be located in geostationary orbit around the Earth, and it will supply its energy to latitudes between 60° north and south. There are two primary reasons why. First of all, most of the world's population is concentrated between these two latitudes, 60° north to 60° south. Below the latitude of 60° south lies solely the continent of Antarctica, which is almost completely uninhabited, and above the latitude of 60° north lie regions such as Norway, Sweden, Denmark, which have already taken into account these renewable sources of energy. So, now that we have discussed about space-based solar power in general, let's look at its advantages. The advantages of space-based solar power are varied. There will be no need of environmentally problematic mining operations which are needed in coal to extract coal, natural gas and oil. It will supply energy 24/7, 365 as I have continuously mentioned, which is the problem with today's renewable sources of energy because they are highly influenced by natural factors. There will be minimal cost of management because there is no working capital needed. Once the satellite is launched into orbit, it will supply energy continuously without any need of any maintenance, regular maintenance. And this form of energy is also clean and sustainable, and the countries that adopt this technology will be energy independent. So, potential use case scenarios for launching a satellite like this would be first ground based testing, which is currently going on in many countries. So, this technology will be tested on ground, and small test satellites will be launched into orbit to see the efficiency of these satellites. The second one is small scale launching of satellites to regions where first of all the electricity costs are very high, where we can provide this energy at a lower cost, and second of all in places where resources are deficient, in rural regions, in islands, in deserts where energy production is not high, and we can also supply energy there because rectenna arrays can be situated anywhere and everywhere on the Earth. And the third, which is the large scale implementation of the satellite, will aim at larger prototypes of the satellite which will supply energy to highly metropolitan cities like Delhi, Mumbai etc., and these satellites will substitute these resources like coal, natural gas etc. Space-based solar power has seen immense development as time has passed. From being an idea into a science novel, it has developed into an idea but closer to reality. With developing technologies, increasing efficiencies and reducing costs due to development of reusable rockets, the idea of space-based solar power has now been edging closer to a reality. But we still have a long way to go. Research and development can still continue, the efficiencies can still increase, we can still make a much bigger project. So, space-based solar power might not be at the finish line, but we sure are close to it. So, I would like to end my talk with the quote that necessity is the mother of all invention. This was a small input from my side. Thank you all so much.